for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded and a copy of the slides and recording will be available for viewing later today. This can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Agostino.
Good morning, everyone. Welcome to the webinar. I'm Agostino Panico, and I will be your presenter for today. As some already said, the webcast title is Model Domain Deception, Risks, Issues, and Potentiality. Who am I? I am a security researcher. I'm one of the organizers of B-Sides in Italy, and I'm more than happy to share with the entire community the research work that I've done. So what we're going to cover today, we're going to have a quick introduction about cyber deception, the common issues and risks that are related to deception. Then we try to map the attacker mindset, focusing on the targeting cycle. Then we analyze some peculiarities of the domain environment, and we do a quick demo with a fake APT that we call APT 6969, in which we do a threat modeling before, and then we do the evaluation of the deception capabilities. After the demo, we analyze some of the risks related to the deception issues and the possibilities, the potentialities that we have. The conclusions and a Q&A session. So let's start the webinar with a small story. A couple of years back, I was in US for a research project, and I hitchhiked across the country for 6 months almost. During this time frame, I was almost on my own, so no money, no special resources to use. So what I had to do is trying to ask for money to people to help me out during the travel. The aim of the research project was understanding how the human behave in different circumstances. Now, as you can imagine, the first time I asked for money, it was a complete disaster. I have done a sign in which I wrote down, please help me, I'm broke. Can you please help me buy something? But this sign didn't work. But then I realized that I can actually change a little bit the sign to see if the people react in a different way. So I use this one. I wrote it down on the sign, to agree to prostitute, please help me. At this point, you can imagine the reaction of the people. Most of them were laughing, looking at the sign. And what comes out of it is, in 2 hours, I raise up 120 bucks plus 25 bucks Walmart voucher. And that was amazing. You understand from this story how the people react. I was the same guy. They react in different way. And this is actually the focal point of the deception. Now, Usually, in all the security conference, you see Sun Tzu cited, but I'm from Italy, so I'm not going to cite Sun Tzu. I cite Niccolò Machiavelli. And I want to introduce the deception with this quote. Men are so simple of mind and so dominated by their immediate needs that a deceitful man will always find plenty who are ready to be deceived. And this is actually the focal point that we are going to cover during the webinar. So, what's cyber deception? The goal of the cyber deception is to detect in an efficient way the attacks that are coming from a threat. Using deception, we try to misdirect the attacker. And we also try to understand which assets are already being compromised, from where the attacker is coming from in our network. Based on this conception, we have some focal points. Those are the focal points that are almost always covered by deception vendors. If you talk with every one of the deception vendors out there, they say that with their product, they manipulate the one thing that the attackers relies on. Why? Because the attackers expect that the network in which they are is a real network. So they try to manipulate the real network to deceive the attacker. They provide instant gratification to the attacker. They go beyond, and this is really common from the deception vendors, they go beyond security implementation. And on the downside, they simplify the implementation and the maintenance. The point is, let's try to understand those focal points, trying to understand if they are correct or not, or they are limited in a kind of way. Let's start from the first one, manipulating the one thing that the attackers relies on. Now, this is something that doesn't take in consideration the planning of an offensive cyber operation. Now, if you talk about script kiddies, some activist group, this is correct. They didn't respect deception in place. But if you start talking about APT groups, some cybercrimes group, they plan the operation beforehand. They invest a huge amount of time in the planning. And during this planning, if you have deception capabilities in place, they will find out using OSINT, UMINT, and so on. So this focal point is not completely true, because it doesn't take really in consideration the complexity of an offensive cyber operation. Second focal point, providing instant gratification. That's interesting. Now, let's focus a little bit on the meaning of the term gratification. The definition of gratification is satisfaction of pleasure when you get something you wanted or you work for. So to provide gratification, you need to know what the attacker is looking for. You need to know the target of the specific offensive cyber operation. The point is, in 95% of the cases, we don't know the real target. And we are going to know the real target only later on. Third focal point, going beyond common security implementation. So what do we mean as common security implementation? We talk about defense in depth, firewalls, intrusion detection system on the network and the host, proxies, and so on. Going beyond those, it's something that can be done only if the organization correctly implement those mechanisms. The point is, how many organizations implement correctly those kind of mechanisms? Really a few. Let's look at some examples, like this one, like this one, like this one, like this one, and one of my favorite, this one. Great, right? How many organizations leave default username and password, admin? If you look on Shodan, you can find a bunch of those. So let's focus now on the fourth point. It's mostly a risk, actually. It's not an issue. Most of the vendors say we simplify the implementation and the maintenance. Okay. How many of those perform an evaluation of the simplification costs and the associated risk that we have with simplification? I know that usually people say we need to try to keep it simple. But sometimes this kind of implementation cannot be too simple. Otherwise, it's too easy to spot. And on the other hand, most of them use a general purpose approach. You can use deception for every target. But in reality, we have too many variables. And to simplify all this huge amount of variables that we have, we actually need a lot of work. And sometimes cannot be done. On the other hand, the community around deception, it's not so huge as security systems. So we have a lot of deception tools that are open source, that are freely available, but sometimes those tools are poorly maintained. Why? Because nowadays you can't make out a business out of deception still. And another simplification risks is that most of the environment in enterprise are based on trust. Let's say like Active Directory. So in which way we can simplify something, some implementation that is built on a complex infrastructure, like the one from Microsoft. So that's something to think about. So let's, after the evaluation of the focal point of perception, let's try to understand what's the attacker mindset. Let's analyze one of the buzzwords of today's security, APT, advanced persistent threat. So what's the mindset? Now, advanced doesn't mean technologically advanced. It means that they have an organization behind direction. It means that they have logistics, they have planning, they have an actual organization. This is the real advanced part. It's not technologically advanced. That's secondary. It's the organization that make a threat advanced. A persistent, a focus on the long run. They don't want immediate gratification. They are not looking for immediate gratification. They are looking for long run goal. So what they use basically as mindset, as a cycle for their approach. I know that many of you have already heard about the OODA loop. Now, the OODA loop is a cycle that is used mostly to have quick decision process to improve the decision process in some scenarios where competition, where where competition is involved and where the ability to react to changing circumstances should be fast, because that reaction leads to an advantage against the opponent. So the OODA loop is basically built on 4 stages. So we observe the situation, we orient ourselves, we decide, after the decision, we act. Now, why the OODA loop is so useful from an attacker perspective? Because the OODA loop actually makes the attacker elastic and resilient to the defender actions. On the other hand, most of the attacker's kill chain can be mapped on the attack framework. Now, what's the attack framework? Attack means adversary, tactics, techniques, and common knowledge. So it's actually a database. It's a big common knowledge of all the possible attacks or possible TTPs that can be used by an attacker. We have a lot of phases. We have, as we can see in the slides, we have a planning phase, the pre-attack. And then we have the act phase. we are going to see that actually the planning phase is crucial, also for the defender. As we can see in the attack framework is built up on the kill chain from Lockheed Martin, mostly. It's an extension from a setup point of view. So we can map out the act phase on the deliver, exploit, control, execute, and maintain phase on the kill chain. And we have initial access, execution, persistence, pre-escalation, defense evasion, credential access, discovery, lateral movement, collection, exfiltration, command and control, and then we evaluate the impact. Now, if you look at the MITRE framework, rarely you can evaluate the impact for specific APTs. You can evaluate the impact for some activist group, some cybercrimes group, and so on, but not for APT. Because it's really difficult to understand the impact of an APT, the real impact. Other than to understand what's the attacker mindset, we need to understand how they decide in real time, so using the OODA loop mostly. How can we map their attack phases on public available for sources like the MITRE attack framework in a way to have all the TTPs that they can use, but we're still missing something. One of the basic things that we are missing is the targeting cycle. So targeting cycle is something that comes from a military environment, military world mostly. We have a 6 phases cycle that start with the commander objectives. So in our case, it's the long run goal. So what's the long run goal of our threat? This is what we need to evaluate. This is what we need to assess. And only if we understand the long run goal, we can actually implement correctly deception. After the long run goal, what they do, they start the targets development and the prioritization. So from this point of view, you see, not everything is the same in the environment. They develop the targets based on the long run, and they give them a priority. They analyze their own capability. So they analyze which kind of capability that they have and how they can use those to attack specific targets. Using all those information, we have the decision from the commander and the force assignment. At this point, we have the planning after the decision, mission planning and force execution. So you see, in this small circle, we have the attack framework. So the attack frameworks cover only one of those bubbles. After the mission, we have the assessment to understand if the long-run goal are met. So as you can see, using the targeting cycle in conjunction with the MITRE attack framework give us a clear view of what's the process. So what we can call it is an attack framework, the targeting with attack framework in an OODA loop style. And looking at those, we see the difference from a tactical perspective and the operational perspective. And this is something that is still missing in nowadays security evaluation. Now, if we merge all the this concept together, we have a clear view of what the attacker process and the attacker mindset is, at least for advanced persistent threat, and also for some cybercrime scope. So if we think about the focal point, what's the immediate gratification in this case? It's really difficult to evaluate an immediate gratification, because the immediate gratification that is considered by deception vendors is on a tactical level. But the real goal, the real target, it's not only tactical, it's operational. Comes from an operational perspective. These concepts are really, really something that should be the basic cornerstone if you want to implement deception capabilities in your own environment. So let's focus on some of the key points of the attacker mindset. So if we analyze historically the offensive cyber operation, matching the OODA loop style, the attack framework, and the targeting makes clear what the deception system should care of. So the deception system should drive the attacker on a deceive target according to the real one. But we need to know the real one. Deception system cannot be general purpose. It's a key failure if we implement deception capabilities with the general purpose approach. We only slow down script kiddies. We should be aware of the threat that we are facing. So the first thing that we need to do is we need to do a threat model of what is against us, what's the attacker against us. The deception system should be integrated in the production environment and should represent a preferential path to reach the target based on the threat TTPs. So basing after our threat model, we analyze what are the TTPs related to the specific threat. Based on the TTPs, we design the deception system, building up something in the production environment that should represent a preferential attack path to reach a target. this deception system should be constantly maintained and updated to match the threat TTPs and the threat evolution with new TTPs. In this kind of situation, in this kind of environment, we need to focus a little bit on some of the most common infrastructure that we have out there. Active Directory mostly. So a lot of enterprise environments are built up on Active Directory. Why? It's the leader of the market actually from this point of view, because it's easier to maintain compared with others. It's easier to build up compared to other solutions, and provide what are the basic features, what can be considered the basic features in an enterprise environment, like authentication, authorization, accounting. The point is, this kind of infrastructure is based on trust and on the resource sharing. So this is the key risk that we have. Now we can see how many, what's the market share of this kind of infrastructure, looking at what the red teamers are doing. Now, if you look at, if you check out the C2 matrix from Jorge Urquilas, you have the link in slides. If you check it out, you can see that a lot of C2, C3 framework are mostly designed for Active Directories. Really a few of them are designed for Linux or macOS environment. So if we look at the MITRE attack framework and we try to map in which phases the domain environment peculiarities impact in the kill chain, we can see that mostly they impact in the persistence, defense evasion, credential access, the discovery, lateral movement, and collection. We also have some parts of impact, some partial impact in command and control, execution, command and control, exfiltration, but it's really limited. So let's focus on the one provided here. So let's do a quick demo about this. Now, I hope that many of you are familiar with MITRE Attack Framework Navigator. It's a wonderful web app, freely available, that can be used to dynamically access the MITRE matrix, the attack matrix. Now, what we are going to do, the first thing, as we have seen during the presentation, the first key point that we need to cover to deploy deception capabilities is threat modeling. So we can model the threat from a tactical perspective, because this is the only knowledge that we have by now. From a tactical perspective, we try to map, to model the threat using the MITRE attack framework. Now, in this case, let's see, we use only Windows environment. We are in a Windows environment, for instance. So, and we select the, can you see the web app or not? Sam, can you? Okay. So this is the web app, the MITRE web app. So we try to model. So let's start up with some basic information that we have. Let's see that our threat is based on APT28. Okay. And APT29. We also add those. And then we have TURLA. Okay. Let's say that after the threat model, we come out with this situation. In this case, just for sake of simplicity, it's a merge of APT28, APT29, and TURLA. Now, as you can see here, we have a bunch of TTPs. What we are going to do, we can't impact the initial access. Unfortunately, it's really difficult in a domain environment, only in a domain environment, impacting the initial access. So the first thing that we can impact a little bit is the execution. So looking at all the TTPs, we need to pick a couple of TTPs that can be actually useful for us, that can be well monitored by us. So in this case, I say, let's say PowerShell, it's an option. Absolutely. And schedule a task. Okay. So doing this, what I'm trying to achieve, I implement the exception to make those resources easily accessed by the attacker. So I try to design their attack path. We go into persistence. Now, which kind of persistent mechanism we want to whitelist from a defensive perspective? I think schedule a task. PowerShell profile, it's an option. And logon scripts. As you can see, we can map a little bit the attack path. Then we have privilege escalation, but with privilege escalation, we are already using PowerShell profile schedule task. What we can add valid accounts. Why not? So valid accounts is an option. which kind of defense evasion we want to whitelist based on the attacker TTPs. Modify registry and file deletion. No. Let's deobfuscation. It's an option, absolutely. So registry modification. Okay. And deobfuscate the code files or information. Credential access. We can have credentialing files and network sniffing. Discovery, network sniffing, files, directory, and system network configuration discovery, for instance. So, as you can see in this process, we try to whitelist some of the TTPs according to the threat model. This is useful if you want to drive the attacker inside your network. Collection. So which kind of collection, lateral movement, which kind of lateral movement do you want to allow? Remote copy file. Pass the hash. No, too easy. Pass the ticket. So remote copy file and Windows admin shell. As you can see, we are designing the attack path. But this process can only be done, and it's only valuable if the threat model is correct. Now, in this case, for instance, I already done APT 6969, as you can see. I already modeled. It's almost the same of what we are doing here. So which kind of collection we have? Email collection, screen capture, why not? Remember, what the TTPs that we whitelist are the one that we are actually monitor correctly. And which kind of command and control we whitelist. That's tricky. If you think from this perspective, seems crazy. If you try to sell this approach to your manager, you look like, okay, you're telling me that I should be breached and I have to hope that the path you are designing is the one that the attacker is going to take. Yes, that's why it's critical to know which is the threat that we are facing. So we whitelist data obfuscation and commonly used port, exfiltration with data compression, for instance. Okay. Now, as you can see, we define a path. Using this, we try to drive the attacker. How? Now, for instance, if we look on PowerShell, we have a lot of options that we can use. One of the options that we can use is the GIA profiles, so just enough administration. Using GIA, we can actually create a jail for the attacker that looks like It's built on the production machine, but it's a jail if it's built correctly. Now, using the GIA capabilities, we can design the next step. The attacker can only perform, let's say, schedule a task. So they access a PowerShell environment in which only scheduled task is allowed. What the attacker is going to use, scheduled task. And if scheduled task is the one that can give us some extra capability in the network, some extra rights in the environment, they are going to use it because they use the minimum power to reach the goal. Most of the times. But everything should be done accordingly with the according with the TTPs that they have. Now, let's move on with the demo, and I show you a quick output of the demo. Now, can you see the screen now? Okay. Now, as we can see in the screen, we have a domain environment. This domain environment is called windomain.local. That is trusted. You have a trusted relationship with SyncTech Lab. We have a bunch of domain administrators. And it's a pretty common environment. It's not really complex, but it's a common environment. This is the baseline. After that, what we do is clearing the database of Bloodhound. And we upload the second one. So I've done 2 shots too easy to speed up the demo. The second one, it's been implemented. It's been done after the deception, some deception mechanism are implemented. So what we have? Let's see all the domain environments. Now, domain admins. Now, as you can see, we have 2 extra domain users. Now, those users are limited. They can log on only from a non-existent workstation. At least, this is the option that I put in this case. Let's do C-Sync. As you can see, DECDA, it's member of domain admin, but can get change all on the Windows domain, on the windomain.local. Means that we can achieve this is sync rights if we compromise DECDA. So it can be a valuable target. So let's evaluate the unconstrained delegation. Yeah, okay. As you can see, with the unconstrained delegation, we have 2 objects. One is comp1 and one is revert web. Now those workstations are added to the environment, but they are fake. They are not real. So those kind of workstation can be used to deceive the attacker. How? We see that we have some delegation options from revert web and from com1 that can be used to escalate. It's an escalation path. Oh, no, we don't have unconstrained delegation. We don't have Kerberos users. So I show you also this option. We have another user, slave user. Now, slave users. Sure, the past 2 years. Now, as you can see, slave user, we have master user that has generic call on slave users. Now, if we say we put slave user in a privileged group or in a group that can lead to a privileged group, and we put a generic call from master user to slave user, we can design some of the path. Now, I know this is just for a sake of simplicity, it's a quick demo. It's not going to be complete, and I'm sorry about that. But I'm going to share the blowdown files on GitHub, as well as the JSON file from the slide, as well as the the JSON file from the MITRE navigator. In this way, you can play with it a little bit if you wish. So, which kind of potentiality that we have? As seen a little bit in the demo, because in the demo, we've done a threat model. We tried to design an attack path. We implement some of those, and we simply checked it with a blowdown. And I want to stress out, everything is built up using Microsoft feature. So adding SPN, using PAM, using GIA, using the delegation, HEL, DHEL, AD object properties. Everything is done using Microsoft feature. All those features should be used to design an attack path that should be complex enough to meet the attacker capability and the attacker TTPs. What's the long-run goal from a defender perspective? We try to understand, we try to reverse engineer the attacker targeting process. We need to understand what's the long-run goal. This is the real goal that we have implementing deception capability. And this can improve threat hunting capability and actually reduce the security risk and improve the security posture. So as we have seen, the entire process is based on the threat model. So we need to do it right. Otherwise, deception can produce more dangerous than good. Deception, to be effective, should be designed as a threat specific. We don't have general purpose approach. It's dangerous having a general purpose approach. Deception relies on common security mechanisms. Relies on them. It's not going beyond security mechanism. It relies on. So if we are not able, if our organization is not able to implement or manage correctly common security systems, we should not go for deception because it's dangerous. If we don't have a mature and organized way of manage common security system. And remember, the deception is an extension of the attack surface. And while security misconfiguration can be translated in false positive, false negative, like if we have a misconfiguration on the IDS, on the IPS, I have false positive, false negative. A bad configuration in deception capabilities is translated in a complete dominance of the environment. Because we are extending the attack path. And if we don't do it right, we are increasing the risk a lot. So the deception is one of the key features in your arsenal as threat hunting team, but you need a lot of effort if you want to really customize and set up a threat-oriented deception capability. The enterprise maturity should be correctly evaluated, because to deploy deception, you need to extend attack surface, integrate deception in your current cyber defense infrastructure, understand who is the threat you're facing. Now, just on featured work, underline, I'm working on the translation of the attack framework in deception tactics and techniques and common knowledge. This is something that I hope to publish by the end of the summer. And it's something that should be a parallel of the attack matrix. This is mostly based on the description of specific deception TTPs that you can use to mitigate, to deceive specific attacker TTPs. So I hope you enjoyed the talk, and I'm more than happy to answer some of the questions, if any.
Thank you for that great presentation. We do have a question ready for you. However, if anyone else has a question for our presenter, please enter it into the questions window now. The first question, Agostino, is do you present these slides in any other language?
By now, I think that I'm going to present them in Italian, mostly. I'm sorry about that. Mostly in Italian. Italian and English. I can say that tomorrow, tomorrow afternoon, I have a short, not Hindi, I'm sorry. I have a short presentation on, a 15 minutes presentation on Attack EU conference. I have a slot tomorrow also. And it's going to be a quick version of this presentation, but it's still in English.
Okay, wonderful, thank you. All right, last chance for any other questions to come in, people. Okay, Agostino, we might leave it there. Thank you so much for your great presentation, which has helped to bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit SANS/webcasts. You can find your CPEs for all completed webcasts by logging into your SANS portal account, navigate to your account dashboard, then click My Webcasts. You can then download your CPEs on the right-hand side of the webpage. Until next time, take care, and we hope you have you back again for the very next SANS webcast.